Yeah, it's been super fun hearing from a bunch of folks that some of you I knew that you were JRuby users, and then other folks are like, yeah, we used it 20 years ago. We used it 15 years ago. We still have an app in production from 15 years ago. So it's great to talk to everybody. But let's get into it. I'm going to talk to you a little bit about how JRuby can kind of expand your Ruby world, give you more opportunities to use this language, these runtimes, these platforms that we want to be able to use. There's my basic information. This is going on 20 years of full-time work on JRuby. I was a Java architect before that, found Ruby at one of the early Ruby conferences in 2004, and then hooked up with the existing JRuby project that was kind of dormant at that point, and have been working on it full-time ever since to try and bring Ruby to the JVM world and the JVM power and libraries and everything to Ruby. Now running Hideous Enterprises, that's how we are funding JRuby development. If you are interested in making a move or doing an experiment on JRuby, if you have an existing application, we can help out with that. We can be a virtual team member, we can be on your Slack channel, we can answer your questions, we can provide security information, all that stuff. So I'll talk a little bit more about that later. And I haven't been here in almost 10 years. I was at Keep Ruby Weird in 2016 with Tom Annabo, the other JRuby guy. He was presenting. I just came down for moral support, but it's great to be back in Austin. All right, so JRuby. How many folks have used JRuby for something at some point? That's great. It's like half the room. So we'll jump right in here. So JRuby, of course, we're talking Ruby on the Java virtual machine, but that first line kind of scares a lot of people who aren't familiar with the platform. They're like, oh God, now I got to learn how to write Java. No. It is Ruby first, a Ruby implementation. We try to make sure everything feels and looks like regular Ruby, the same tools, the same workflow, the same development process, all of that stuff stays the same. So we are a JVM language and we get the benefits from the platform. I'll get into the details of that later, but the JVM is an amazing platform. You just don't have to use Java. There's many other choices, and Ruby's one of the great ones. We expect that Ruby should just work. So if it's pure Ruby code or a pure Ruby library and something's not working right, let us know. We'll take the responsibility for figuring out if it's our problem or not. We just want to know that everything works exactly the same across our Ruby and other Rubies. There are thousands of applications out there, thousands of companies running JRuby in production. I don't have thousands of customers yet, but we're working on that. If I had one low-level like pro customer for every one of those 1,000 applications, there'd be no problem. JRuby would be fully funded. But we've had production users since 2007. That was like pre-1.0 time. People were so excited about having this potential to use Ruby and Rails on top of the JVM, they jumped right into it. I will showcase a few of the customers that we have today. Hopefully you will be one of them in the future, and we can talk about bringing your apps to a larger world. So the whole point here is that JRuby it represents opportunity, a huge amount of opportunities for all of us as Ruby developers to be able to use the language we love anywhere in the world. There's a difficult time sometimes going to large companies with established technology stacks, big enterprises. They don't want to install this new weird runtime. They don't want to have these C extensions to worry about, the C code getting compiled in production settings. Nobody wants to deal with that stuff. There are libraries that they may already depend on. There may be things missing from the Ruby ecosystem. They may need high parallelism, high concurrency, big data, all of this stuff. And Ruby is not always the right fit for that. But that's where JRuby can come in. It's really enterprise ready. It can run all the same Ruby stuff, but high concurrency, big data, all the libraries, all the benefits of the platform. So that first problem, the enterprise doesn't want to install Ruby. Well, it's an easy answer. The JRuby platform can run anywhere there's a JVM, which is basically anywhere. I'm just running this is on my local system here. You get a JDK, pretty much any vendor is fine as long as it's Java 21 or higher. So I've got a Java 26 running on this machine. I use Ruby install. Ruby install knows how to go and fetch the current JRuby, pulls it down. There's nothing to compile. JRuby is distributed as just a tarball that you unpack, and then it runs. That's it. All it needs is a JVM local to the system. Continue on, we can run our favorite IRB. We can see we're 3.4.5 compatible in this particular version of JRuby. We've got 10.04 that we're running. And then we can actually start calling into JVM classes if we want. So here's one of the built-in classes, Java Lang Runtime. We get our runtime instance. We can get the number of available processors. We can get the free memory. But basically, making all of these JVM libraries just feel like another extension of the Ruby world. So anything that you can call on the JVM, you can call from your Ruby code. A note on compatibility here. I mentioned 3.4 compatibility. That's for the current release that's out, JRuby 10.0. Like 98% of the language and core specifications pass. Other stuff is like fork and weird edge cases that are very Unixy specific. Probably stuff that you'll never run into when you're using JRuby. We share almost the entire pure Ruby standard library with CRuby with standard MRI. And the native bits, we have JRuby versions for almost all of that as well. We are almost done with JRuby 10.1, which bumps compatibility up to Ruby 4.0. So I think we merged this at the end of February. So by 2 months after Ruby 4 was out, we were basically ready to be compatible. I'm just like trying to shove more optimizations and cool stuff in there, so I'm dragging it out a little bit. But we could release this any day. So deploying JRuby, we can get it installed, we can run it on a platform with a JVM. If you want to stick with the same runtime, the same servers that you're used to, something like Puma works just fine. And you can do it the standard Ruby way, run a Puma server, put it behind some reverse proxy, and you're good to go. But you can also take a Ruby application, a Rails application, or a little desktop or a tool application, and use a tool called Warbler. Warbler will turn your Rails or web application into a deployable Java WAR file. Then you can throw that into a Java application server in an existing cloud, an existing infrastructure. No one even has to know. I heard from at least 3 people since I got here that they used to have an application running Ruby, Rails in production that nobody knew was Ruby. Because all they had to do was give it to the production staff, they deploy it on the app server, and it's done. Nothing to install, it's all in one file. You can also do this for standalone jar files if you want to distribute small tools to customers. We have a customer, on the next slide, that uses this to distribute little tools to companies around the world. All they do is send them a jar file, they can run it in their local cloud, learn on their local systems, and it's all good to go. A bit more of the magic under the scenes here. JRuby Rack is basically our proxy between the Java servlet APIs and Rack. So any application that uses Rack as its web front end, that's what can run on JRuby Rack and be deployed as a Warbler. So little Sinatra apps all the way up to big Rails monoliths can all deploy. And then, of course, we run on the JVM. You can pull JRuby into an existing Java app, an existing ecosystem, and just start using Ruby to script stuff and make it a little bit easier for folks to customize the behavior. So a first customer that I wanted to mention, Quantum Inventions, it's a company out of Singapore. They use JRuby to deploy little database tools on premises for their customers. So they package this up. They use Active Record, they use Oracle database with the Oracle drivers for JRuby, send it to their customers, they can run it anywhere they want, they don't have to worry about it. We can also actually obfuscate the code in here, so you can protect your IP. What's inside the actual jar file is pre-compiled Ruby code, compiled to JRuby's internal representation. And of course, nothing is impossible to reverse engineer, but it'd be really hard for them to take that code and do anything with it. So this is an excellent example of putting Ruby places where they just wouldn't be able to do it. They wouldn't get someone to deploy this weird runtime that they're not familiar with. So the second problem here, C extensions. C extensions are the biggest thing that's been holding Ruby back. It makes it hard to advance the runtime, it makes it hard to build JIT compilers and better GCs, and it also represents a huge security hole that a lot of companies just are not willing to deal with. All of our extensions are written in JVM languages, most of them written in Java, but you can write them in Scala or Clojure or Kotlin or whatever you want. They all deploy on the same JVM, they're all subject to the same security restraints as other JVM languages, and usually there's no compilers, no build tools required to distribute any of this stuff. So we're a first-class JVM language, write our extensions in Java, not in secure C code. It all optimizes together too. The C extensions that you write and the C extensions that make up the core of Ruby, that's a hard boundary for the JIT. It can't optimize across that boundary, which means anytime you call into an array method or a string method, that's as far as the optimizations and inlining can go in JRuby. With us, it all is on the same JVM, it's all in the same model inside the JVM's optimizer, and it all inlines and optimizes together. Of course, we've got the JVM garbage collectors that are also excellent. But you don't have to care about any of that stuff. We write the Java side of this. We make it integrate with the JVM so that you can just write Ruby code and get the benefit of the JVM and its optimizations. A little walkthrough of JRuby's architecture here. So we've got our Ruby code that comes in on the left. We parse that into an AST, and then we have a compiler to our own intermediate representation, our own internal bytecode, essentially. We actually interpret that bytecode for a while within JRuby. It's a little heavy to go all the way to JVM bytecode. So we interpret our own bytecode for a little while. Then when methods get hot, when we realize these are important pieces of code, we compile that down into JVM bytecode. And then the JVM takes it the rest of the way. It does something similar, interprets the code, profiles it, optimizes it, eventually turning it into native code. JRuby is actually the first native JIT for Ruby because we just give it to the JVM and that's what it does. It turns it into fast native code. So an example of an optimization that came along recently, JRuby 4 added an optimization for class new. So object.new, foo.new, model.new, whatever. Whenever you construct a new object, the problem was that it had to call out to C code to allocate that object, create the actual physical allocation of it in memory, and then also call back to probably a C-based initialize method or call through C to your initialize method. Remember what I said, whenever you have to call through C in the standard implementation, that's a hard boundary for optimization. It can't do anything. So they basically implemented a special instruction that if it's just a standard allocate plus initialize, it could do it all at once in Ruby and then optimize and inline that stuff back. We've had this for 10 years now. It was pretty easy to teach the JVM how we do allocation and initialization of objects, and it all just inlines and optimizes together. We can see it actually if you go look at the assembly code that comes out of a piece of Ruby. Once it's gone all the way to native, you can see the memory operations where it allocates the object and populates all of the data in it. So a little benchmark to show how much better the JVM can do this. We're just going to do object.new, just simple object creation to see how fast we can do it. Ruby 3.4 with YJIT before the optimization, 10.3 million allocations per second, which is a pretty good throughput. About 30% improvement by adding this instruction, and I think it's actually gotten a little bit better since I pulled this number. But Ruby 4.0 with the class new optimization, 30% better. But then, of course, there's JRuby telling the JVM exactly how to do this, and it just blows it completely out of the water. And I've actually checked to make sure these objects are being allocated, and they are. It's just the JVM is very good at allocating little transient objects, being able to throw them away in the garbage collector. There's almost no GC overhead, and it optimizes so well. This is the sort of feature, the sort of improvement that we get out of teaching the JVM how to run Ruby code. So next customer here, Poshmark. It's a big social commerce marketplace. It's kind of like a Shopify, but a little bit, it's like a Shopify / eBay sort of thing. Hundreds of millions in valuation, something like $1 billion in sales last year. They use JRuby very heavily throughout their entire stack because it scales so well and the performance is so good and the concurrency is so good. They can use the JVM versions of different libraries. They can try out different ones for different reasons, different for performance. They can have a huge amount of data in memory, and it all just scales really well. So the next problem, missing libraries or a library is not cross-platform, doesn't compile right somewhere. We've all run into this with C extensions once in a while. Or the C extension depends on something in the operating system that I've got to go find and I've got to build and I've got to install. And then that becomes part of my supply chain and my security issue to figure out whether that library is safe. The solution here, easy with JRuby. You can just use the JVM libraries that are already out there, already published. No need to compile them, no need to build them. And there's a huge amount of these. Hundreds of thousands of libraries in the JVM world. For just about any feature you can think of, any data format, any graphic format, there's probably a dozen libraries out there already existing for the JVM, and probably like 4 of them are really good. So you're going to find something that works well for what you need. Definitely one of the largest collections in the development world. We're talking 30 years of work on this corpus of libraries. All of them available to JRuby users. You can pull in any one of these libraries into your Ruby code, never write a line of Java, never run a build, Maven build, Gradle build, nothing. Grab the library, start calling it from Ruby. So let's take a look at a more interesting example here. This is a blog post I did a little while ago. You can go look it up. The code's out there as well. Using a library called JFreeChart, which has been around for almost as long as JRuby, like 20 years, but it's still one of the best libraries for generating charts and graphs on top of the JVM. So here we pull in our dependencies. For fetching the dependencies, we have something sort of like a gem file called a jar file. The jar file has a list of Maven dependencies, just basically the namespace, the name of the actual library, and a version. We put those into a jar file. We run lock jars, which is basically our bundle, and it pulls them down into your local Maven repository and makes them available to your Ruby code. Then we can move right along and start importing those classes right into our Ruby code, call them just like their regular Ruby classes. Here I'm populating this 3D data set by using standard Ruby JSON library, standard file.read, pulling those pieces out, shoving them into the elements of this data set. I can create my 3D chart using Chart 3D Factory. We got the basic information, basic headers and stuff that are going to go on it, a little bit of customization. JFreeChart can output PNGs. It can also output SVG and PDF from the exact same code. So however you want to render that or distribute that charting information, you can do that. And there's a couple other backends as well. And then we get this. Very little customization. Obviously, there's a lot of cleanup and improvement that could be done here, but that's like 10 lines of code. And we did nothing to pull in any separate libraries. We didn't have to build any C code. You just pointed at JFreeChart, start calling the code, and you're ready to go. And after watching Amir's talk and being inspired by the Dragon Ruby stuff, I thought, well, what would it take for me to start building sort of a Dragon Ruby on top of JRuby? So I thought I'd pull in SDL, the simple direct media library. It turns out that there's some bindings for the JVM already, part of the lightweight Java GL toolkit. It has bindings for a dozen different graphical libraries. SDL is one that has pretty good support. So there's LWJGL, then the SDL version, and then some native platform-specific libraries to pull in. So I run my lock jars, pull those libraries down. I took their little hello world example and turned it into Ruby code here. Just require in all of those libraries, import the message box class from SDL, and I can display a message box. It took like 5 minutes for me to figure this out. I really wanted to do their other example, which is like rotating gears and some cool stuff, but it's just a lot of code, and it was more than 5 minutes worth of work, so I didn't do it. So here, like, we can actually start building with SDL on JRuby. So maybe the next project will be Dragon Ruby, right? You got to have a J in everything, otherwise they're not going to know what's going on, right? So I mean, there's also, and there's tons of other more practical things that we can do for a business setting, an enterprise setting. There's lots of different graphical toolkits out there, GUI toolkits. Glimmer is a Ruby DSL that has many different backends. It has backends like GTK and whatnot, but some of the most mature are the ones on the JVM. Backing up on SWT, like Mark was mentioning, you can have a backend that uses Swing, but the SWT one I think is the most mature. Same code, now you can run it cross-platform. I know that the Glimmer folks, they actually use the jar dependencies stuff, the lock jars, to package up GUI applications and distribute them. So again, you can pull in all of the GUI libraries, all of the Ruby code from Glimmer, and distribute it as an executable jar file to anybody. And you've got a desktop application that runs anywhere. So that's a lot of fun. Then, of course, Android is basically a JVM-based platform, so all those apps are written in something JVM-like, Java-like. This is an example of a Rubato IRB. Rubato is our framework for doing Android development. And here we have a little IRB, we've got a simple editor, and we can run this code live on a phone. There are actual commercial applications out there that use Android for point-of-sale devices, information kiosks, advertising kiosks, written in Ruby using Android and deployed with JRuby. So the user I want to focus on here, anybody heard of Kami? So Kami is a tool used by millions of students and teachers around the world to hand out homework assignments as PDFs. Kids can go edit those and then submit them back in. Every time any one of those PDFs is changed or submitted to the system and saved, they're using a JRuby backend. Why? Because the JVM PDF libraries are just amazingly good. So they have their big Rails monolith on the front end, but when it comes down to it, all of the actual file processing that's done passes through a JRuby service. That's where the PDFs get generated and then sent back to the front end. So we're thrilled to have them as one of our customers too. So the next problem here, big data, high concurrency. You need to be able to run a lot of data, a lot of concurrent processes. You need to be able to do this and not have to spin up dozens of processes, deal with coordinating between all of those. The JVM is designed for this. I mean, you know, it gets a bad rap as being a big, fat, bloated platform, but when you talk about running huge applications with huge data sets, which we have more and more of these days, of course, this is the way that you end up doing it. So, first of all, garbage collection. Perennial problem for Ruby applications. We're always chasing the next enhancement to the GC in CRuby. With all the work that they do, this is still very limited on how much they can make those GCs better. You've got a lot of C allocation. You've got C extension libraries that are doing their own allocation that the GC can't see. A lot of challenges for making the regular Ruby GC better. JRuby, being on the JVM, it's all just Java objects, it's all the same heap, and these GCs are the best in the world, bar none. GC will never be a problem for your JRuby app running on the JVM. It's basically not an issue. And that example of object.new, the fact that they can allocate and throw away objects hundreds of times faster than the regular CRuby runtime already shows how little JC is going to be an issue. Now, if you do run into a case where you've got leaks or you've got a memory problem, you're doing way too much allocation, there's all sorts of free tools that are available for the JVM. This is a tool I like called Visual VM. On the right side, we've got some basic information about the VM there, how much memory overall it's using, how many threads there are. On the right, this is a plugin called Visual GC. And this is actually a live view of the garbage collector in the JVM. You can see the earlier generations fill up with garbage, they get collected, sometimes objects get promoted to older generations. You can see graphs over time. You get the nice sawtooth there. If you see that sawtooth going up, then you probably have a leak. There's even buttons on here where you can say, give me a heap dump right now. Let's see what's taken up all that memory. That'll be regular Ruby objects from JRuby. You can take a look and figure out where you've got a problem in your application. So then on the concurrency side, and a little bit about isolating different applications, isolating processes, Ractors are the big thing that's coming around for Ruby. Anybody using Ractors or trying to use Ractors for anything? Yeah, it's people playing around with it a little bit, but it's a very difficult API to work with. You have to make sure you're only passing immutable objects everywhere. That means you're allocating a lot more because you've still got to make modifications. You've got to deal with that sort of hassle. JRuby threads are already 100% parallel. So you can work with a concurrency safe data set in memory, shared memory, have dozens of threads working on it, all cranking through this process, and actually get the benefit of all of the cores on your system with a single process, one application. One JRuby instance can basically replace all of your workers that you've got in production. We've heard from people that took, I think it was an application that was using like 20 Amazon extra large instances, and they brought it down to like 15 mediums. So if you've ever priced out how much it costs, that's tens of thousands of dollars of savings in hosting costs just by using the resources of the system better. There's also another API coming along in Ruby 4 called Box. It's experimental, but it's basically a way to have like isolated Ruby namespaces. This one requires these files, this one requires those, and they don't see each other. Well, JRuby, just being a JVM library, we can run many Ruby instances within the same JVM if you want. They can all be running separate applications, and indeed, like a JVM application server, when you deploy it, those are isolated instances of JRuby that don't see each other, they're fully isolated, and they run with all their own threads and do their own work. So a little example here, this is a benchmark. In this case, this is the threaded version. There's another version of this code that uses a Ractor, and what we're trying to do is just concurrently load in JSON files to be processed as rapidly as possible. We've got hundreds of these data files, thousands of them, and we want to pull them in as fast as we can. So if we look at threads versus Ractors on CRuby, throw some threads at it, it's not really concurrent. We don't really get much gain out of it. There's a little tiny bit of improvement because sometimes it can release that lock and the C code can run in parallel. Ractors help only a tiny amount. This is slowly improving. I think it might be up to like 1.3 or 1.4 times faster with Ractors right now, but it's difficult. You're still contending for the same memory allocation pipeline, the same GC, all of that stuff is still single-threaded and synchronized. But JRuby on the four core system, we're getting like 4 times. Trivial to do. And this isn't even worrying about concurrent safe data. We just want all these threads to do work at the same time, separate work. Easy to do, and it scales right up. Logstash, anybody's familiar with Logstash? Of course, everybody's got some Logstash stuff. That's a JRuby-based application, has been since 2012, and it was basically impossible to build this thing on regular CRuby. The distribution requirements, being able to run it anywhere in anybody's systems on their on-premises, to be able to handle all of the concurrent logging that happens when you use this as your one place that all logs go, all of the Java libraries and servers that they're able to deploy on. It's a huge example of why JRuby works for doing a commercial product that needs to run everywhere and run at huge scale. The other one that we've got as a customer, Substitute Alert. This is a tool that is used for substitute teachers. You sign up and say that you're available to sub in these levels of classes, this different subject matters, and then they will send out notifications that there is a substitute request. So thousands of concurrent requests going all over the place, built on JRuby, really could not be done without the abilities of the JVM and the parallel capabilities here. And then finally, this is a little quote that was just on our JRuby chat recently from a new user who started playing with JRuby like 2 months ago. JRuby's excellent. I don't even code for any MRI anymore, and I don't miss it. And that's a huge testimonial to making it feel like Ruby, but still give you all of the power of that platform. All right, so wrapping up here, talk about the future of JRuby. I mentioned JRuby 10.1. I've got tons of optimizations. I'm gonna have to just cut it off at some point and then like get this release out. But a lot of cool stuff coming, greatly reduced memory footprint. We're taking advantage of some new JVM features. Lilliput is mentioned here. It actually shrinks all JVM objects by a substantial amount. So JRuby applications are just going to be smaller in memory. We're using a project called Project Layden that can do pre-optimization of Ruby code so you can get up and running faster. We don't have the same startup time, warm-up time issues. And there's just so many things happening at the JVM level. You just upgrade your JVM and your JRuby app runs faster. It's just amazing. We're really excited about all the work they're doing. So then there's this final problem. I don't know how to use JRuby. I don't know how to get this into my workflow. I don't know how to start building stuff and deploying stuff on JRuby. Well, the answer to that is the company that we started. This is how we fund open source JRuby. We do all of our development in open source, all of our support in open source. But if you need an expert that can help do that conversion in your system, can help support your existing JRuby application, that's what you can talk to us about. So expert support for JRuby exploration, JRuby maintenance and support. If you've got specific bugs that are holding you back, or if you need security guarantees, we will do all of that. We will be your JRuby expert, your virtual team member on your Slack, wherever you need us to be that. Just released the new site, so go check it out. We've got all the information there about different tiers, all the way from a basic like $100 a month, easy one to do, up to whatever scale you need us to help out with your applications. And our friend here, Mark, at Fascination Works, did the redesign. Really thrilled with what he came up with in a short time. I think we started 2 weeks ago or something and got it out. started last Friday, and got a complete new site design up that looks gorgeous. It's beautiful. So if you need something done quick, Mark's the one to talk to. And I want to have more discussions about this. So if you're interested, if you have more questions, we can talk at the break. I'll take a few questions after the talk. But I thought we'd just grab a table out here after the conference is done. We can grab a beer or a cup of coffee, and I'll tell you whatever you want to know. Let you know how we can get JRuby into your systems or make it run better. And that's what I've got. You can come to me for stickers. There's also, I forgot to mention, this users MD file that's in the JRuby project. If you are a user currently, please pull requests, just give us the basic information. It helps everybody out there know what people are using JRuby for and what's the possibility. But that's all I've got. Do we have some time for questions?
Let's give Charles a round of applause.
All right, thank you.